Welcome to the Beam Corner channel. My name is Chris, and in this video I will continue your favorite series about data tree structure. There is one component in tree ribbon that actually utility is not quite obvious and straightforward. I'm talking about relative item. In the practical example I will try to explain how this component works and how to use it properly. Hope you're gonna to like it. To be updated and learn all secrets of Grasshopper, join our community. It's easy. Go to learngrasshopper.com, click the join button, write your email address and click the confirmation link in the email you will get from me. You will be getting now all the latest videos, learning materials and interesting links about Grasshopper directly to your inbox. And now, let's go to the video. As I said, today I will show you how relative item component works. You can find it in sets and trees. The easiest definition of component is: relative item enables you to extract two trees from a single tree. The output of the component is dictated by offset mask input. So as a result we have two output trees, item A and item B. Component has also four inputs. As the first one, a tree which we would like to extract from. The second one is an offset in the mask form. I made a whole video about masks in Grasshopper. You should watch it in order to understand how to use them in the relative item component. Quick and short reminder. The mask and offset are built in the same way, have two components. The branch offset and the item offset. Branch offset is defined in curly brackets, while item offset is in the standard bracket. Next we have wrap inputs in the boolean form. One for path and one for item. The wrap works in the same way as in the insert item component. Component asks if replaced element should be deleted from the list or it should stay. Okay, enough theory for today. The whole point of the relative item component is to create data pairs. Let's go to a practical example and we'll try to find some pairs, in a way that one point from the data tree will find his partner by using a map. And the map in our case will be offsets. On the screen you can see 18 points with the visible position in the data tree. In the panel we have defined offset. So in this example we are going to offset first branch by one position and the item by one position. In the practice we will start with the first tree data, which is 0, 0, 0. So to find a partner for the first element we need to use our offset. So we need to add 1 to the first path and 1 to the item. So as a result we get number 1 in the first path and number 1 in the item. And Grasshopper will do the same with the rest elements in the first path. Now we can go to the second path, and the first item it will be 0, 1, 0. And now we are going to try to find a partner for them. So we need to add 1 to the first path. So it will be 0, 2, and we need to add 1 to the item, so it will be 0, 2 and 1. And after the second path, Grasshopper will proceed to the third path. And in this case, it's impossible to find a partner for these elements, because if we add 1 the first branch, we will get 3, and we don't have 3 in our first branch. So solution for this example, it will be 2 rows from the first level and 2 rows from the second level. First one it will be output as item A, and second one it will be as the output item B. To visualize that I will connect all the points in the first level with the partners on the second. Okay, let's go to another example. To create an advanced data tree, I have copied several arches and have placed many points on them. To simplify example, we have just one data path. And as before, we are going to find a pairs of points. In the first relative item, our mask is +1 in the first path and +1 in the item. Okay, let's start with the random element. It can be 0, 10. As you for sure know, this element is placed in the path number 0 and with the item number 10. So if we add 1 to the path and 1 to the index, we will get 1, 11. So we have two pairs. And now we are staying with 111 and we go to next one. So if we add 1, we'll get 2 and 12. So we found another pair. And now we can connect all the points from item A with the points from the item B. Another component have a mask +1 from the path and -1 from the index. So if we start with 0, 11, we need to add 1 to the path, so it will be 1, and add -1 to 11, so we get 10. So the result will be 1, 10. And we stay with this point and we go to next one. So we need to add again 1 to the path and -1 to the index to get 9. So we get 2 and 9. And now we connect item A and item B as a result of relative item component. Some engineers use this component to make a bracing in the structure. That's all for today. Hope that you now know how to use the relative item component. If you like this video, hit the subscribe button and leave a comment. Thanks for watching, see you next time. Have a good one.